Okay, so my next question is 2010, question 10b. Okay, we haven't actually done making benzoic acid using phenylmethanol, recrystallizing benzoic acid, or determining its melting point. I will be doing those three as a set of experiments on Tuesday week, hopefully, when we're back. I will go through it though, okay? So, describe with the aid of a label diagram how the melting point of the recrystallized product could have been obtained. So there's a few things we need to have here. First thing is that we have an aluminium block. That aluminium block is heated over a hot plate, and inside this aluminium block I have two things. Okay, and there's a bit of a hole here in the aluminium block so I can see through. The first thing I have is my sample, which will be my benzoic acid in our case, and the next thing I'll have is a digital thermometer. So we are asked to describe with the aid of a label diagram, so that's the aid of a label diagram. I'm going to now describe. So we place our benzoic acid, so our sample, in, and this here, where my sample is called a melting point tube. We then place the melting point tube in the aluminium block. We then also place a thermometer in the block as well. We heat the block, and what will happen is that my benzoic acid is a white solid, okay? So when it is melted, it changes from a white solid into a colourless liquid. Remember, melting is the changing of a solid into a liquid. Okay, so what we're going to do is we're going to look at our thermometer and we're going to note the temperature range over which the sample melts. Okay, the next thing then is that from the melting point you are asked to show how it's purer. And the purer the product, it's going to really conform to three things. Firstly, the higher the melting point is. Okay, so the higher the melting point, the more pure the substance is. The second thing is the narrower the range, the more pure the substance is. And the third option then is that the melting point temperature is closer to its actual value. Every single substance really has their own unique melting point. Melting point is considered a characteristic property. Okay, so again, I will be looking at that when I do the experiment, but always purer means it'll have a higher melting point, it'll have a range that's narrower, and it will have a temperature that's closer to its actual value. Then you're asked to name the instrumental technique that could be used based on an absorption of a unique set of low energy electromagnetic radiations. Lowest energy is infrared spectrometry. And finally then you're asked one important use. It is used as a preservative, benzoic acid.